In this episode, weird logarithmic equations coming up, back into action. Hey guys, today I will show you how to solve weird log equations. And by the way, I have separate videos on how to solve basic kinds and more harder types, and you could jump into that. Say you run into something like this. Look at the first one. The log of x, the log of variable, appears to be an exponent, the index or power of that expression. And what do? Well, there is another property that can be applied over there, and all it says that if you have a raised to the log to the same base a of any number, let's say b, it simplifies, it reduces to just b. You could think of this kind of this base a, this big base a, and this little base belongs to the logarithm. They can kind of cancel each other out. It might help you to remember that property. Now, we cannot apply it straight up at this point. We can tweak, we can adjust our equation and fit it into that property. Since 25 can be thought as a 5 squared, I'm going to replace this 25 with 5 squared and rewrite it. So I'm going to rewrite this as 5 squared and raise to that power, raise to the log to the base 5 of x. So this whole thing is going to be raised to the log to the base 5 of x. And you still have this 64 on the right side of your equation. Now, since you have, just keep simplifying and do algebra as much as you can. Since you have these two powers, so one thing gets raised to another thing, another power, you could use properties, power properties. So these powers need to be multiplied out, so by using power and power property for indices. So it becomes 5 2 times this log 64, and since this number 2 multiplied out front of your log, so we don't want this. So we want to somehow to match it, to fit it into that formula. So this 2 is kind of sticks out, so we don't want this. To get rid of this, we could use just a power property for logarithm. And these 2 we can bring up as a power for argument, for x, for whatever you have inside of your logarithm by using a power rule for logs. So it becomes 5 raised to the log 5 x squared. So again, these 2 we can bring up, we can move as a power for the argument, which is x, of your logarithm, and it's still equal 64. And now we are there. So we could simply at this point apply this property. So since you have base, these bases, they are precisely the same, 5. So we could think of this kind of cancel them, and we can get rid of this bulky power and involving log expression. So it just becomes, look, whatever you have as an argument of your log. So log disappeared, log drops out also with 5. So it becomes just x squared. So whatever you have as an argument of your this log expression, so it's just x squared, and you still keep whatever you have on your right side. Alright, so it's getting better and better. And now just algebra, no log at all. We left it behind, and since you have simple quadratic, you could use a kind of square property for this quadratic. So your x becomes just positive, and all you do, take a square root from both sides of your equation, and since taking a square root and squaring, they're opposite, they're inverse operations of each other, they undo each other. So we could get rid of this stuff over here. And be careful when you take a square root of a number. So basically, generally speaking, you would get two versions, two possibilities. So positive and negative version of this number, and that's important because many people forget to take a negative version. They just write positive. So to be precise, generally speaking, you would get two versions, plus minus. And since 64 is a perfect square number and square root of 64 is just 8, since 8 times 8 gives you back that 64, you will be left with just plus minus 8. Now, at this point, you have to check your solutions. You have to check your roots just by finding the domain of your original expression or original function. Look at this. Your x appears to be an argument of logarithm, and the domain of logarithm is only positive value for x. Your x, from what are you given from your original expression, cannot be a negative number because it's an argument of logarithm. So by definition, your x is always positive from here. Your x has to be greater than 0. That's your restriction, that's your domain for your original function or original expression, if you will. So from here, your x cannot be negative 8. So that value of negative 8, that's called an extraneous solution, as they say. So, and that extraneous solution has to be excluded, has to be thrown out, has to be tossed away. And you will be left with getting just x equals 8. Here, your x is 8. That's your only one solution, only one root for that original equation. And if you like, you could check it out by just plug it in into your original equation and see if it works, and it will. Now, suppose you have been given something like this. Looks again intimidating at this point. So you have log of log. So your argument of your equation shows up to be 2 times a log again. So you have kind of log is nested inside of log. Anyway, the way you would do is just by applying the definition of log. Since you have a number on the right side, you could turn it into and link it to exponential version of that form. So since taking log and taking an exponent, they're inverse, they're opposite operations of each other. So each log can be linked, can be connected to its exponential or index version. So let's rewrite it. And all you do is just grab this little base 2, you raise it to whatever you have on the right side, it's 1 in this case, and you set it equal your argument of your logarithm, or that middle part that hasn't been used, hasn't been touched yet, and just rewrite it. Now it becomes, so it's equivalent. So again, you grab this 2 to the first power, set it equal this argument, log base x of 25. And since 2 to the first power is just 2, this one can be replaced with just 2. And I'm going to rewrite it in the reverse order. So I'm going to write it log to the base x of 25 equals 2. It's the same thing as 2. So it's getting better, and now we have only one log. So again, you could use the exponential version for that log. So you could connect it to its exponential version. So by grabbing this x, raising to the second power and setting it equal 25. So let's do it, go ahead. So it's equivalently x to the second power equals 25. And now we arrived at something like what we had before. So it's basic kind of quadratic equation. So you get your x, likewise similarly what we did before. So it becomes positive and negative version of 5, since 25 is a perfect square number and principal root of 25 is just 5, since 5 squared or 5 times 5 gives you back that 25. So you would be left with plus and minus 5. Again, at this point you need to check for extraneous solutions. So sometimes the algebra you do might turn up that these extra solutions, that it says extraneous or bad solutions that basically don't work for your original equation. So look at your original expression, and since x happens to be a base of your logarithm, so there are some restrictions for the base, such as x has to be greater than 0, and also x cannot be equal 1 since it's a base. So from this one what we got, so x cannot be equal negative 5. So negative 5 happens to be an extraneous solution, extra bad solution, and has to be thrown out, has to be tossed away, cast out. So, and you will be left with getting just x equals 5. That's your only one solution, only one root for that log equation. And again, at this point, if you like, you could check it out by plugging it in, by substituting that x equals 5 into your original equation, and check to see if everything works, and it will. Alright, the last type, in case it comes up. Log to the base 4 of something like 2 raised to the 5x plus 3 equals x squared. Well, yeah, looks shocking, I know. Anyway, try to simplify. Keep in mind all properties of logs, all properties of indices. They might come in handy. And first of all, try to somehow, is a kind of a pro tip, try to somehow to get rid of logs. Because you don't want this. You want to turn your equation into kind of algebraic form. You want to get rid of logs by using properties, something like what I did before. Or for another types, you could jump into my other log videos. I have a couple, and see that explanation. Look at this. You have x appears located as a power of that exponent, which is basically an argument of your log. It's kind of tangled, complicated. And also x appears on the right side as an x squared, so kind of power of x. Anyway, since you have a power over here, a power of your log, you could simplify it down by applying a power rule for log. And all it says, if you have a power of your argument, a power of the inside of your log, that power you can bring down, you can drag it down, you can pull it down as a coefficient in front of your log. And we could apply this to that left side. So your entire power in this case, it's 5x plus 3. So this is your power of your log. So drag it down in front of your log as a coefficient. So, but be careful. Make sure you take all these powers. So 5x plus 3, it's basically this linear expression. So it becomes 5x plus 3. And I'm going to draw the parentheses because this entire expression gets multiplied by log to the base 4 of 2. And it still equals x squared. Now, log to the base 4 of 2. So basically, it can be calculated, it can be simplified, and if it's a little bit confusing and difficult for you, you could do it right off the side just by rearranging it into exponential form and figure out what x makes this work, what x makes this true. Or you could, if you're kind of experienced one, you could just ask yourself, what power this little base 4 has to be raised to get these two. So 4 to that power, what power this little base 4 must be raised to produce these two. And it might be not that obvious, but the answer is a power of a half, since a square root of 4 is just 2. So the square root basically means a half power. So since, again, the square root of 4, it's the same thing as 4 to the half power is just 2. So 4 raised to this a half power gives you this argument 2. So, and logarithm, it's always the exponent, the power from that exponential version. So the answer for that log is just a half. Again, if it's still difficult for you to figure out these things in your head and get the answer from top of your head, just do it off to the side. It's perfectly fine and you're good to go. Now, just replace this entire log with a half. And I'm going to write it in front. So just a half. You have this expression 5x plus 3. And it equals x squared. So no log. We got rid of that. Now all you do is just that basic algebra. Apply your basic algebra skills, your essential algebra skills, and solve it out for x. It seems like it's gonna be standard classic quadratic equation, and basically it is. Just since we have a half, just get rid of this by multiplying by 2 both sides. So you multiply by 2, but both sides of your equation, so you multiply by 2 and clear off this fraction, and this side gets multiplied by 2. So it becomes just 5x plus 3 equals 2x squared. So since you multiply by 2, and rearrange it and turn it into a standard form by writing 2x squared as the first term, and I'm going to bring all of these terms to the right side by subtracting them. So, and normally, typically, we write it in kind of decreasing or descending order. The highest power of x there and the lowest. Now, all you do is just solve it for x. So what x is basically, so generally speaking, you have two values of x because it's quadratic. And all you do is just, since you have this leading coefficient is just 2, and you have the constant -3, all you do is just multiply them out. It becomes just -6. And you want to find two numbers that multiplied to -6 and they add up to -5. So multiply to -6 and add up to -5, and it's gonna be -6 and 1. Since -6 times 1 gives you -6, and -6 plus 1 gives you back -5. And by the way, if you need a help to how to solve these quadratics by kind of magic X, and I have another episode, a fast trick to solve quadratic equations, you could jump into that explanation. Anyway, the next step, you need to divide these two numbers by this leading, by this first coefficient. I'm going to do this quickly, and you simplify these two. So since 2 goes into 6 3 times with this negative in front, so it's gonna be just -3, and this fraction is already into your simplest form. And the next step, you need to switch the signs. So you need to switch the signs in front of these numbers. So the first one becomes 3, and the second x is just -1/2, and that's your axis. That's your axis for that log equation. Well, there are two, and at this point, if you look for your original equation and try to figure out the domain, so the domain of your original expression, so basically it's all possible x's. There are no restrictions for x. So, but again, if you like, you could just check it out to make sure by just plugging it in into your original equation and see if it works, and it will. Well, that's your kind of weird log equations. Alright, thanks for watching and train your brain. And by the way, if you need help with solving normal, basic types and more harder types, I have a couple of videos, and you could jump into that. Thanks for watching and train your brain. I know everyone hates maths, but if you like my video, please hit like, share with your friends, leave the comment down below, and be sure to smash that subscribe button so you will not miss out my new release.